Hi folks, thanks for coming here. Today we'll be talking about Superpower, your Android apps with machine learning. So you'll see how you can integrate machine learning in your existing Android apps, or start with implementing machine learning in your Android apps, and how it can essentially superpower your Android apps. We'll also specifically be seeing what's new with Android 11 for machine learning and how you can get started with it. So hi everyone, I'm Rishad, and a bit about me. I'm currently a high school student from India, and I'm also a TEDx and TEDx speaker. A part of the things listed down on this slide, I've often represented my country and won a few international competitions and hackathons too. And if you want to know more about me, what I do, feel free to check out this URL, all my coordinates over there. I also love research, so I've published quite a few research papers about AI and mathematics. Feel free to check them out. Before I go on and start with the presentation, I would also like to thank Sai Paul, who's a machine learning 3D, Khan Leviat from Google, and Hoy Lam from Google, who have helped me in reviewing these slides and putting together a better version of these slides. So let me just tell you who the ideal audience would be for this talk. It would essentially be mobile developers who are looking for ways to build smarter applications. So if you are looking for some way to build a cool application, let's take an example. You want to do face recognition in your Android application. This is the right talk you have come to. We'll see how to build smarter applications. It would also be mobile developers looking for ways to integrate ML into their existing apps very easily. So you already have an app, and you already have a team which has been working on a model. This talk will show you how to integrate them. This is the right talk you have come to. So first off, why care about ML in Android? So I'll not talk much about this, so we can get to the cool stuff very quick. But I'm sure all of you know how the number of Android devices have increased exponentially. I'll give you no numbers, you already know how the number of Android devices have increased exponentially, and are also aware that ML is revolutionizing almost every industry. So it makes sense to make this power of ML available to everyone. And how do you do that? Well, you deploy them to mobile devices, or you have them usable on mobile devices. And all of us already use products like Google Photos, Gmail, or Prisma, and it is due to ML that these are so much powerful. Today we are also going to majorly talk about on-device ML. So since I told you we are going to talk about on-device ML, the next question would come, okay, why should I care about on-device ML? So we'll talk about on-device ML today due to some reasons, which we'll soon see. And Android 11 has a lot of cool stuff for on-device ML. So first off, what's this hype about on-device ML or ML on edge all about? The idea is to use ML such that, opposed to the traditional approach, I no longer send my data to a server or some cloud-based system, which would then do the ML for me and return me the output. What I do instead is I get my outputs or inferences from my ML model on the device itself. That is, I no longer send data out of my device. And yeah, this also means I do all the processing stuff, the inference stuff. So if I have some tasks like I need to clean the data, I need to pre-process the data, I do all of those and then run my machine learning model, which would essentially give me the inferences on the mobile device itself. So all of the pre-processing, inference, any intermediate steps are done on the mobile. Okay, so well, you might be wondering, okay Rishit, you told me what on-device ML is all about, but again coming back to the question, why is this something I should care about? So the first thing let's address this question. The first thing that will come to your mind is power consumption. I spend a lot of power sending or streaming my data continuously to a server or some cloud hosted system. And sometimes it becomes infeasible to do so, especially in cases where you are trying to do video analytics or are working on streaming video data. It takes a lot of power to send your data to a cloud hosted server and then receive outputs from it. But yeah, worth a mention, in some scenarios, the opposite could also hold true. If you have some heavy pre-processing steps, it could happen that you spend a lot of power doing the pre-processing steps and you end up using more power. But in a lot of cases, this is something you would like to consider. Another important thing to consider is the time it takes me to get the output, or essentially run the model. For real-time applications, this is a pretty important aspect to consider, since again, I'm sending my data to a server, waiting for the server to do the ML, which would essentially be fast, and then getting it back, doing some processing on it, and then showing it to the user. It would just be a lot more faster if done on the device itself. And this is also expensive in terms of network availability. I should have the bandwidth or network to continuously send the data and receive inferences from the server. So that is also something you would have to look for. And finally, security. I no longer send data to a server or a cloud-based system. If you remember, I no longer send data out of my device itself. So what does this mean? I've essentially enforced privacy. So now let us discuss what Android 11 has for you. What Android 11 has for you in terms of new things to do on-device ML specifically. As I told, Android 11 has a lot of cool updates for on-device ML, so we'll be seeing them today. One of the most coolest updates is the model binding plugin, or as you might say, the machine learning model binding plugin. So what the ML model binding plugin does is you can make a fair enough guess from what it would do from the words model binding. And before I move to telling you what model binding plugin does is, it's available with Android Studio 4.1 and above. So yeah, you need Android Studio 4.1 or above to use the ML model binding plugin. The ML model binding plugin makes it super easy for you to use a TF model in your Android app. You essentially have a lot less code to write. That calls the TensorFlow Lite Android support library. You can import the TF Lite model, read the input-output signatures of the model, and use it with just a few lines of code. And nothing to worry about if you haven't worked with machine learning in Android earlier. But for the folks who have worked with, you might know that you needed to only explicitly convert everything to byte arrays. You no longer have to do that. If you don't know what this is all about, no problem. You'll be able to understand the rest of the talk just for the folks who have used machine learning in Android before. Another thing I love about this is, with this new plugin, is you can easily make use of GPUs and the neural network API very easily. That is, hardware accelerators, make use of them. With the model binding plugin, using these hardware accelerators or enabling these hardware accelerator options have never been easier. Using them now is just a dependency call away and a single line of code away. Isn't that cool what you can do with the model binding plugin? And of course, this would make your development a lot more faster with the features we just talked about. And as you have easy support for integrating your models, easy support with the inferences, and we'll soon see how all of this works, but just a bit about ML model binding plugin in overview. So let's see how you can do this. So first off, I need to import my TensorFlow model. Or my TensorFlow Lite model. That would be a better way to phrase. And I would import my TensorFlow Lite model with metadata. So Android Studio now has this new option for importing TensorFlow model. Just right click on the module you want to import the model in, and I don't know if you can see it clearly on the slide, but under the other section you now have an option called TensorFlow Lite model. So once you click on that, you will get an option to import the TensorFlow Lite model, and this is how you essentially import it. Once you do this, you can just pass in the path for your TensorFlow Lite model. It will import the TensorFlow Lite model for you in a directory in the module called ML. So it will make a directory for you called ML and import your TensorFlow Lite model in it. You would also be able to use the TensorFlow model from this ML directory. And as you can see on the slides, adding the dependencies, the GPU dependencies is just a click away over here. So now from my model metadata, so if you open the TensorFlow Lite model in Android Studio, instead of giving you something like type not supported or something like that, what it will do is it will show you the model metadata. I can know a lot of important stuff which I actually need to use the model from the model metadata, like input output shapes, what license the model is under, what architecture the model uses, a description of the model, and a lot more. And you can add a lot more too. So as I said, you can see this info by opening the TF Lite model file in Android Studio. So in this screenshot, I have imported an open source model made by me to classify between rock, papers, and scissors. So in front of the camera, you just show it rock, papers, or scissors, and it will tell you what you have shown. So that's the model I made, and we'll be using it as an example. So all what we talk about in this talk will be applicable to other kinds of models, but we'll be using this as an example and making it to the end. So yeah, let's finally now start using the model. So for a streaming inference, which is most probably what you want to do, and also what I'll be demoing at the end of this talk, that is live image classification. The easiest way would be to use camera X and pass each frame from the live camera feed into a function which can perform the inference. So as of now, what I'm interested in is the function that performs the inference. So you'll see how easy it is to do this. A sample code for this is also seen when you import a TF Lite model, which you can use. So we'll start by instantiating a RPS model, or remember the model I just told you about, the rock, paper, scissors model. I've called it the RPS model in this stage. And with the plugin, once I imported the RPS model, I imported rps model.tflite file. What the plugin did was it created a class for me with the exact same name. So my model file name was rps model.tflite, a class of the exact same name. As you can see in this slide, RPS model was created for me. So now I have a class called RPS model, and I'm just creating an instance of the model. Once you do this, you need to convert your data into a form which we can use. So we'll convert it into a tensor image, and we'll do this from a bitmap. If you have not used the TensorFlow Lite interpreter earlier, no problems, you'll still be able to follow along. But for folks who have used the TensorFlow Lite interpreter, you know that you need to convert your image to explicitly to byte arrays at this point. You no longer need to do that. And yeah, I'll also feed in an image proxy in this stage. So now we'll pass in the data. let's take this line by line and see how the inference comes along. So first, we'll process the image and get the outputs. So the object I made was called RPS model, and I'll use the process method on it. Pass in the TF image we just created on the line above this. So it'll be, so I'm just passing TF image to the process method. This will give me the outputs for the model. So once I run the code highlighted in this slide, what I'll get is my outputs or my inferences from the model. What these inferences would be are essentially an array of probabilities. So I would have an array of probabilities saying what my probability is for each class. So in this case, I had 3 classes: rock, papers, and scissors. So my model will tell me what is the probability I have for each class. So that is what the process method would return me for a particular image. So this is passing in a single image. I want you to remember that I'm passing in a single image from the streaming input. I'm taking a single image, passing that in, and after which I perform a descending sort on it. So because I want to show the user the label which has most probability first. So let's say I showed the model a rock, and it tells me, okay, I think this is a rock 90%, I think this is a scissor 5%, and so on. I want to show the user the rock label first because, well, it has higher probability, so I want to show it to the user first. I may even skip showing the other 2 labels. That is completely up to you and your application. But since we are trying to make an example application here, I want to show my user the rock label first because it has the highest probability. So I'll perform a descending sort and then take up the first n results. So in this example, the model we are building, it has 3 labels. Not a big deal. I can show my user all the 3 labels. But let's say you're working with a cool model, with a big cool model, which has 1000 labels. Well, I don't want to show my user all 1000 labels, so I just added this line of code where I ask you how many labels you want to choose. And yeah, you can, it's essentially an array. You can modify it as you might want. Let's say you want to just take up the label which has lowest probability. I don't know why you would want to do that, but let's say you want to do it, you can do it. It's all up to you. So after this, I'll add the label corresponding to each entry in the output, so I can show it to the user afterwards. And that's pretty much what you need. Just a few lines of code, as you can see on the screen. And yeah, that's pretty much what you need. Integrating and running models made super easy. So you can see I took in my data, I converted it into a tensor image, passed it to the model, which then gave me outputs and showed them back to the user. So very less lines of code, super easy. And remember, I also told you enabling GPU acceleration or hardware acceleration in general. Let's see how you can do that. So I told you back then, it's a single line of code away and a dependency call away. Let's see how that works out. So let's say I want to use hardware acceleration. In this case, I'll give you an example with the GPU acceleration. So what I'll do is I'll make an options where I specify it to use GPU, model.device.gpu, and build it. In the instantiation part, a part of my context, I would also pass in this options. This would unpass the options as an argument, which would allow me to use GPU. So what did you use? You added one line of code and you added the GPU dependency. So you also need a dependency to make to support this. So that was also just a dependency call away. So it also makes it very easy for you to use the neural network API for acceleration to do even more. And with Android 11, you have a lot of cool updates to the neural network API too, including asymmetric int8 weights and a new quality of service API. But I'll leave that for some other talk. And yeah, this was a bit about how you can do hardware acceleration. Let's talk about the other major development, a newer ML kit. So I'm expecting a lot of folks here to know about ML kit, but if you haven't heard of ML kit earlier, since I say a newer ML kit, if you haven't heard of ML kit earlier, no problem. Let's see it. Let's see a bit of it. So this is a brief about the services that MLKit offers you. It has a couple of new services like ink recognition and pose detection too. But yeah, MLKit allows you to use state-of-the-art models for all of this, state-of-the-art pre-trained models for all of this. You can do all of these use cases very simply with MLKit. You can also you can do all of these and the new ones showed over here. So yeah, it's pretty useful. Just a bit about the services that MLKit offers. So let's talk about the new MLKit now. And before I move on, I'd like to tell you MLKit is now available even without having to use a Firebase project. You can now use MLKit without creating a Firebase project. So earlier what we used to do was create a Firebase project, link it to my Android application, and then be able to use MLKit. That's no longer the case. You don't need to create a Firebase project. As I said earlier, a lot of updates with Android 11 for machine learning are focused on on-device ML due to the benefits I mentioned earlier. The new MLKit now has better usability for on-device ML. We'll soon see how it all works out. But yeah, the MLKit image classification and object detection and tracking models now also support custom models. What this means is I have a state-of-the-art pre-trained model, and with that, on top of that, I can run just a custom TF-Lite model file. So essentially gives you a lot better customizability, as I can run a TF-Lite file, a TF-Lite model on top of my state-of-the-art pre-trained model. What this also means is if you're working on some generic use case, like a specific kind of object detection or a specific kind of pose detection, let's say object detection does a lot of stuff, but you need something which can classify between, okay, I don't know, maybe a human and a dog. Simple example, could be anything. You don't need to go ahead and train the model right from scratch, take out a lot of data, spend out a lot of resources. You don't need to do that. Use the state-of-the-art pre-trained model by MLKit and train and very easily train a TF-Lite model which can with very less data and run it on top of the object detection model with MLKit. So yeah, it's the best thing to use if you're working on some generic kind of use case. Let's see this in code and let's see an example of this. We'll implement this. So again, let's take an example which we can build while in the talk, and of course this is applicable to any other example, your own models too. But I'm just showing you this example so you can have a good idea and we can build together something in this talk. So here I built a model which can classify different food items. So I'll start off by first setting the model and specifying the TF-Lite model file for it. So this is the TF-Lite model file, which is a food classifier. And yeah, it should also be added as an asset. You can do that very easily. It should be added as an asset. So as I said, this will run on top of the object detection model with MLKit. So you can customize these options a bit. So let's get to the part where we run the model. So you might see some syntax similar to the previous example here. I'll process my image. As you can see, I process my image, and then what I essentially do is I have all of these listeners, that is on failure listener, on success listener, and so on, which are essentially tasks. So they need to be attached for every run. So I'm just saying process the image, and if it is success, draw something on the graphics overlay. So if I see something on the screen, if I see something from my camera, I'm telling it, okay, you need to draw it on the screen so my end user can see it. So that's how easy it makes the inference part. What I also want you to look at is some customization options. So you have limited customizability with MLKit because it is a TF-Lite model running on top of a pre-trained model. So you have little customizability with it. I've shown some options over here which you can use. So first off, one option which I've shown over here is stream mode. So I want to do streaming inference, so I've set over the stream mode. You can try changing it for batch inference or upload an image and then inference type of things. I've also shown another option which you can customize, which is the confidence threshold. In this case, I'm saying 80% is my confidence threshold. Feel free to customize it. And there are a few more options which you can take a look at from the docs. Okay, so well, that was about MLKit. You saw how easy it makes just a few lines of code to get wonderful performance. I'll not talk much about this as I'm running out of time, but we talked today about what to do after you have a TF-Lite model, deploying it to edge devices and so on. But let me talk a bit about how do you get the TF-Lite models, or a bit about where you can make or where you can find wonderful TF-Lite models. So there are a few examples of the TF-Lite model maker in the demo repo or the repo which I created just for this talk. You can check them out. But in short, the TF-Lite model maker is something that was released by the Android team just this year, just in 2020, and it allows you to create high performance models with your data. It is super easy to use and allows high customization too. So it's super easy to get started with TF-Lite model maker, and it makes super easy for you. You can also find state-of-the-art models on TF Hub. As an example, the food classification app that is present in the repo, which we just made an example for, was taken from TF Hub. In a lot of cases, you might find just the model you need, just the model for your use case on TF Hub itself. So, and it also has a lot of features. You can see I have something saying, okay, I just want TF-Lite models. I want nothing else. You have those features over there. You can simply do searches and a lot of cool stuff. You might find wonderful models over there. You also find there is essentially a cool repository, a collection of well-documented state-of-the-art models, and you also have models from the community. So these are not just the only publishers, but these are the only publishers I could fit in one slide. So you get to use models from the community. I also have a couple of models on TF-Lite, TF Hub. Feel free to check them out. Okay, enough of talking. Let's get to code. Let's get to demos. Here's the GitHub repo for this talk. It has everything implemented that we talked about today. It also has the source code which I used to create the TF Lite models. I would urge you to take a look at TF Lite Model Maker, which is what I used to make these models. So now let's see a demo of the ML model binding plugin in action. So yeah, first off, I'll instantiate my model, and I had a RPS model.tf Lite, so I have a class with the same name, RPS model, and I'll instantiate it. I then have a TF image, so I make a tensor image from a bitmap and pass in the image proxy. I then want to perform my inferences, so I use the RPS model object, use the dot process method on top of it, pass in the TF image which we just created on the line above it, and that will give us the inferences as a probability of arrays. So I'll then just add a descent, I'll sort it by descending, sort with the highest confidence first, and then take the first end results to display to the user. In this case, I have 3 labels, so it's not much of a problem, but remember me telling you this would be a huge problem if you had a model with 1000 labels, so when you can just take up the top 5 or 6 labels. I'll then also add my output label and output scope so I can later show it to the user. And that is all I need to inferences with ML model binding plugin on Edge. What I also want you to see is if you want to enable GPU acceleration. So first off, I'll create an options and say that I want to use a GPU. So I'll just say model.device.gpu, specifying that I want to use a GPU. I'll build it, and once the model's option builder is created, I'll, instead of this kind of code where I instantiate my object, instead of just passing it the context, I also pass it the options which I created just over here. And that is how easy it is to use GPU acceleration in this. Now we'll be seeing the live demo. I always love live demos. Have a real phone in front of you and show a demo. So that is what I'll be doing now. And yeah, I'll just be showing single demo since I'm really out of time. So let's see one. Here is it. Let's hope my laptop can make a good background. Let me try putting something in front of it. Let's put a rock. And oh, see, it shows it's a rock with almost 75% probability, 80% sometimes. So that is pretty good. That is pretty good that it has done. And that was all about my talk today. Thank you for tuning in. I hope you learned something from this. Feel free to send me your questions or any further discussion on Twitter or LinkedIn or on any other social media you find me. Be sure to share any projects you make with me through Twitter, LinkedIn, or any other social media. Thank you.